Okay, we've got a ball that represents the wind, and we are going to illustrate gradient. Okay, now we're going to see the Cheerios falling again. So here's air molecules falling. There's high pressure, high pressure, high pressure, high pressure. And notice it's spreading out and diverging at the surface. Yahoo! And if we were to grab our ball, grab it real quickly here, and it's to come down the pressure gradient. Here it says wind, okay, and it would go down the pressure gradient like so. Okay. So as you know, a hill would create a ball to roll down just like we showed, or if I had the back of my whiteboard, the ball will roll down, and so that's just simply gravity and the gradient, right? Well, we can also do that for wind. Wind is simply going to blow from where those molecules stacked up, just like with the Cheerios, all the way down the hill. It goes from a high pressure to a low pressure. Okay, so now we see a hill, but normally we have to represent that in 2 dimensions. Okay, so here's a profile of the hill. Here is looking at the hill from the top down. It's the top view. Now, just like a contour map, let's use this as an analogy for how do we map out that pressure gradient. It's the exact same comparison between gravity taking the ball down and wind going down the pressure gradient, but it will be represented by isobars. So let's back up a step and talk about contour lines, because contour lines are going to be very, very similar to isobars. Okay, so let's say we were going to walk around this small hill at sea level. That's what we'd represent right here with this first line at 0. If we were to walk around it at the exact same elevation at 20 feet, that would be the line we would walk. Okay, notice that the hill is steeper on the left-hand side here and not as steep on the right-hand side. Notice that the contour lines are showing that it is much more spaced out. If you were to walk down the hill, you'd have a lot more time to get to each one of those imaginary trails. Whereas if you were to go down this way, of course, you would run across them quickly. And just one more time, let's say you were at 60 feet above sea level and you were to walk around exactly level on that elevation, you would follow that line. These are known as contour lines. Okay, so continuing on with this analogy between contour maps and isobars, let's take a look behind me here. So, for example, here we have some maps that have lines in them, isotherms. For example, this one right in here is the heat around the United States. And notice there's a discrete line between, let's say down here in the bottom, I'm looking through the camera, but you know, this is like 70 degrees over here on the key, and it goes like to 75, 80, something like that. And then right here in the middle, same kind of thing. You can tell just by the color of the map where it's hot, but notice there's a discrete line between each temperature isotherm. And then finally here at the bottom is actually a weather map you might see with a high and low pressure, and I'll zoom that in there a little closer. Okay, so let's take a look at some points of isobars. Okay, so over here we have number 1, maps pressure. Okay, these lines help us map pressure. I'll show you some more examples. Number 2, these are lines of equal pressure. Okay, just like contour lines that go around on the 20-foot elevation and the 40-foot elevation and the 60-foot elevation, these are lines of equal pressure. In the case of the contour lines, by the way, those are lines of equal elevation. Okay, same analogy. And then finally, when I show you some examples, these isobar maps or isobars will show you the direction of the wind and the speed of the wind. Okay, so specifically looking at the map, the average sea level pressure in July, we can see with the isobar lines that we have a high pressure system sitting off the west coast of the United States. And this is what keeps Southern Oregon and Northern California and Southern California quite dry at this time of year. Here we are in October, and we're looking at temperatures again, 80s, 90s. What I mentioned earlier is we probably won't get rain until after, significant rain until after Halloween. And I'm going to show you another one where a low pressure system works its way off the Aleutian Islands. Moving across at the same latitude, a high pressure sits off the Azores, off of Spain and northern Africa. Okay, so the isobar lines show us where these dominant high pressure systems are. Another Mediterranean climate with a dry summer and a dry fall is off of Chile, Santiago, Chile. And also in the southern part of Africa, we also have a Mediterranean climate. Let's take a look at the low. Moving on to January. Okay, off the Aleutian Islands and Alaska is a low pressure. We call that Aleutian low. Over here off of Greenland and Iceland, we have another dominant low pressure system. And that is what provides weather storms fronts for Europe. And same thing here in Washington, Oregon, and California. We start to get our storms coming in off of this low pressure. And you can see some other ones here in the Amazon, another one down here in the southern part of Africa. Here's one sitting off of Australia, okay, out here in the middle of the Pacific Ocean. So very useful. And then let's look at our final one. Okay, and here is one of the United States. Kind of a generic one showing high pressure here off of, let's say, Idaho and in the Pacific Northwest. Okay, so this would be, let's say, in the late summer, early fall. And there's a low pressure down here in the southeast. So a few things about isobars is that, they can show us, hey, winds always blow from a high to a low, and they will turn to the right. We're going to get into that with the Coriolis force, but we can tell, hey, the winds are going to go this way. And then also, if these lines were closely spaced, just like the steep contour lines, if this low, for example, were over here, these lines would be very closely spaced, and that would tell us the speed. So in summary, we've been looking at the winds. Okay, let's go back here. We know that winds always blow from a high to a low. It's an attempt to equalize pressure. We use an analogy of a hill, the high, and a low, downslope, and we looked at gradient. Okay, in this case we called it pressure gradient. If we have closely spaced isobar lines, that is a steep pressure gradient. Okay, and that means that the winds, taking a look at this map, would blow from a high to a low. If these lines were closely spaced together, like I just showed you, we would have a stronger wind, and we know the direction of the wind, and that does it for isobar lines.